So this is 1.3, which is piecewise functions, and I like piecewise functions, and here's the reality of it. Piecewise functions are easy if you know your mother functions and you can make a table. They really are. They really are. Like this little piecewise function right here. It's got y equals x squared on it. It's got y equals a constant on it. And it's got y equals x on it. It has pieces of those three functions. And that's what it means to be a piecewise function, multiple pieces of different functions. I'm not going to write down that definition. It's a common sense definition. Here's a conceptual understanding. It's modeling with a piecewise function. So Alani has a summer job as a lifeguard. She makes 8 hours for up to 40 hours each week. If she works more than 40 hours, she makes 1.5 times her regular pay, or $12 an hour for each hour over 40. How could you make a graph and write a function that shows Alani's weekly earnings based on the number of hours she worked? Okay. Let's see here. Now, if we work 40 hours, that'd be 320 bucks. I'm going to do a freehand graph as opposed to being limited by the XY axis. So for every hour she works, and let's do groupings of 5 hours. So 5 would be 40 bucks. 10 would be what? 80. 15 would be 120, 20 and so forth. 20 would be 160 and so forth. It looks something like this, okay? 5 hours, so forth. Now, what happens is, here's the problem. Let me redo this one. Let's do 10-hour intervals. So 10 times 8 is 80. We'll count by 80s. 160, 240, 320, and then something's going to happen. So if she works 40 hours, 40 times 8 is 320 bucks. Something happens. After 40 hours, she starts getting overtime. Overtime is 1.5. So overtime is 1.5 times 8, which is 12 bucks an hour. So here, if she works 10 more hours, she doesn't make 180. She doesn't make $80. She makes 120. If I'm still counting by 80s, I'd be at 400. If I have to add 120, about 440. Kind of hard to show it, but the slope is going to get higher. It's going to take off a little more. That's what happens on a graph. You can see it's two different pieces of two different functions. Now, that's the idea of the graph. How do we write a function? Well, we have to have a function that covers up to 40 hours and then after. So we need two pieces. And we can use y equals mx plus b for both of them, but that's the idea. We have two different functions. We have a function for up to 40 hours, and we have a function for after. And it's the after one that bugs kids because of how we do things. So let's do the first one here. We'll use y equals mx plus b. She makes 8 bucks an hour, and there is no, if she doesn't work, she doesn't earn anything. It's just y equals 8x. So maybe we should make this pay. Let's see here. Summer job. I guess we could do income as a function of h. Let's do earnings as a function of x. It's just 8x. Now, this is only good so long as x is stuck between 0 and 40. That's one of the other issues we have with piecewise functions, is the domain concept, and domain just tears kids apart. Oh, domain hurts kids, but it's good between 0 and 40 hours. Now, the second piece of the function, she doesn't make 8 bucks an hour, she makes 12 bucks an hour. But it takes over right here at 320. It has a starting value of 320. And then there's this. You can't just feed it like 41 hours because it would be way off. You actually have to take away the hours you've accounted for. Kind of rough, isn't it? So there's a lot going on there. And as we do more and more of these, we'll try and make them clearer. But that's kind of how it works. All right, so we've already done that. We wrote the equation. Model the piecewise function. How much will Lonnie earn if she works? And let me copy down what I've done using correct notation here. We had earnings as a function of x, and it's a piecewise function, so no surprise, we use a big old master curly bracket. We have 8x if the time is between 0 and 40 hours worked. And then we have 12 times x minus 40 if we have worked more than 40 hours. That's what the piecewise function looks like. And this is the part that bugs kids. I know it bugs kids. Now, if I'm going to do 37 hours of work, I'm going to be using the top equation. It's simply 8 times 7. Sorry, 37. So 8 times 30, I believe, is 240. 8 times 7 is 56. You put them together, she gets $296. That's not a lot, man. That's not even my Walmart bill for the week. 43 hours, I'm going to have to use this function. I forgot the plus 320, didn't I? There we go. I need the plus 320. I'm going to feed it into 12 times x minus 40, 43 minus 40, plus the 320. And this piece becomes 3. 3 times 12 is 36. And she gets $356. This equation writing makes a lot more sense if a kid has numerical sense. If a kid doesn't have numerical sense, this is hard to do. I remember being a kid with these, and I remember I slept a lot in math class. So I started coming up with these by being good with numbers and making up things that worked. I used my numerical sense to come up with those ideas. Graphing. Graphing is ridiculously easy if you know what mom looks like and you can make a table. And that's the idea. Like when I see 4x plus 11, I think that's a line. Because it looks like y equals mx plus b. When I see y equals x squared minus 1, I know that's a parabola. Okay? And when I see y equals x plus 1, guess what? I know that's a line. All I need to do is make a table. Plain and simple, make a table. So I'm going to make some tables. And then I'm going to draw what I know it looks like. Now, here's your domain. This is saying I can feed it things between 10 and negative 2. And I realize that there's no equality at negative 2, and we can fix that. But we're going to feed it a 10 and a negative 2. And our output is 4x plus 11. If I feed that thing a negative 10, I'm going to have negative 40 plus 11, which is negative 29. If I feed it a negative 2, I'm going to have negative 8 plus 11, which is 3. Now remember, there's no equality. I'm going to put an open dot there. So back 10 and then down 29 would literally be off this grid somewhere way down here. Okay? Back 2, rise 3, open hole. That's how you solve the issue of equality. You say there is nothing there. You have to have the open dot there so that people can look at it and go, oh, there's no value there. There's nothing there. X squared minus 1 from negative 2 to 2. Let's see what happens. And by the way, this should look like a parabola, right? Now, here's one exception to just plugging in the two endpoints. If you're going to cross the y-axis, put a 0 on your table. We'll plug in from negative 2 to 2, and we'll put a 0 in the middle. So if I feed it a negative 2, a negative 2 squared is 4. 4 minus 1 is 3. If I feed it a 0, negative 1, which, by the way, is shifting, right? It fell 1. If I feed it 2, 4 minus 1 is 3, because parabolas have symmetry. Same on the left as they are on the right as far as y is concerned. Now, negative 2, 3 has already been declared open, but what's about to happen is the parabola is going to fill that hole. I also contain 2, 3, and I have 0, negative 1. And I know that that is a parabola. So I'm going to draw a parabola. The next last part is x plus 1, which is a line. I know it's a line. I'm going to feed it a 2 and a 10. If I feed it a 2, 2 plus 1 is 3. Now I shouldn't be that, so it'd be an open hole for it, but the parabola closed it. If I feed it a 10, 10 plus 1 is 11. 11 should be up there. We have quality, it's closed. Now, what's the domain of this thing? Well, the low x value was negative 10, the high x value was 10. And we're going to do both interval and set notation. If we do interval for domain, notice the equality, bracket negative 10, comma, 10 with a bracket. If we do set builder, all values of x such that x is stuck between negative 10 and 10 inclusive. Range is your y values. The lowest y value was negative 29, and the highest y value was 11. So the range is negative 29 to 11. Or if we like set builder, all values of y such that negative 29 is less than or equal to y, which is less than or equal to 11. Ta-da! And I know what you're thinking. You're thinking you already hate this. You hate this because you still ain't figured out y equals mx plus b from 7th grade. You hate this because you haven't figured out what your mother functions look like. And you hate this because you don't know how to make a table. Those are all basic skills. I understand the hate that kids have towards math, but you turn around and you make it 10 times worse on yourself. A goal of yours this year should be to not hate the subject, to try your best and see if you can at least tolerate the subject. This is actually super easy stuff. You just don't want it, and I can't fix that. All right, let's look at these three equations here. Remember, f of x is fancy for y. One piece is y equals 3. That's a horizontal line. One piece is y equals negative x. That's a slanted line, negative slope. The other piece is y equals 3 minus x, which you might think of as negative x plus 3. These are all just lines, nothing more. Nothing more. We'll just make a table for each of them. So the first one, it doesn't really matter what you feed this thing because the output's 3. If you feed it a negative 4, even though you shouldn't, the output's 3. If you feed it a negative 1, the output's 3. So back 4, rise 3, open hole, because look at that. There's no equality. Back 1, rise 3, solid dot. There's that piece. All right, we've got this piece here for negative x. We're going to feed it 0 to 2. If we feed it a 0, it's still going to be 0. If we feed it a 2, it's going to be negative 2. We have equality, so nice closed circle there. And then 2, negative 2 is also a nice closed circle. All right, moving forward. The last piece of this thing is 3 minus x. And it is valid from 2 to 4, but not inclusive, so they're going to be open holes. 3 minus 2 is 1, 3 minus 4 is negative 1. So 2, 1 exists, but it's open. And I put that in the wrong spot, didn't I? 2, 1 exists, but it's open. And 4, negative 1 also exists, well, it's open. And there's that little piece. Now here's the fun part. What's the domain? Well, we travel from negative 4 to negative 1, parentheses because open hole, bracket on the negative 1, solid dot, and then we jump to the next piece, so union with. This piece starts at 0, stops at 2, and you'd be tempted to write that. You would be, and I'm going to go back and fix this, you would be tempted to write 0 to 2, union with 2 to 4. You see how you have a bracket on the 2? We don't need to talk about that. So this is wrong. This is 0 to 4. And that's going to be tough, realizing when I can kind of close that hole a little bit and not need the parentheses there. But x is allowed to be 2. It is. X is allowed to be 3. X is allowed to be redonkulously close to 4. But not quite there. All right, range. The low y value is -2. And as we rise across this one, we cover everything up to 0. And this one will take over and get us close to 1. So from -2 to 1, but I can't actually be 1. And then I make a jump up here. And anywhere on this line, y has a value of 3. Fun stuff, huh? It is what it is. Write a piecewise defined rule from a graph. So you should notice that we have 3 linear pieces that make up this graph, and they're not going to be hard for you to do. The blue piece is super duper easy. It's literally a y equals mx plus b. I can think of that as y equals, what's the slope here? You really can't tell just by looking at the graph. So we go right 1 and we rise to -1. We were at -4. So the slope is to rise 3, run 1. 3x minus 4. I'm going to do the green piece next because it's the easiest one on here. That is a horizontal line. And it is a horizontal line that has a y value of 8. And now I'll do the red piece. Okay? Or sorry, and it's orange on this one.
Mr. Kemp.
I'm going to find its slope. Remember, slope is y minus y over x minus x.
Go ahead. Are you at the bar?
It actually has a slope of 1.
Yes. I have 4 young ladies that wants to see some baby
Now I'm going to do y equals a times x
All right,
minus
send them
h
up.
plus
I'll do
k
it.
to get the equation. The slope ended up being 1. X minus, I'm going to pick this point, minus 1 plus 4. Kick in the distributive property, y equals x minus 1 plus 4, and y equals x plus 3 is my final output, my final answer. And that makes sense if you kind of follow along the graph. It looks like it probably crosses at 3. Now, let me see if I left more room on the next page, and I did not. It's time to write a rule. And on the rule, you're going to have to think about where these things are valid. We're going to work from left to right. This is the first thing from left to right. It was 3x minus 4. We'll call it f of x equals. The first piece is 3x minus 4. It is valid from x values from -2 to 1. So we would say -2 less than or equal to x less than 1. No equality because we have an open hole. The next piece is the orange piece, and its equation was x plus 3. It is valid between 1 and 5. 1 less than or equal to x less than or equal to 5. And the equality symbol needs to be there. Now, an unwritten rule about piecewise functions is you don't need to include equality twice. So since I've included equality on this 5, when I write the next one, which is just 3, I'm going to leave off equality on that value of 5, and I'm only going to give it to the 8. And that is a piecewise function for that graph. Now I'm going to pause real quick. Be right back. And I'm at. So this is supposed to be a try it. And the good, I'm looking at 18 minutes, so I don't want to do all of these because I don't want to bore you with too much time. And I guess maybe we'll look at this one right here, okay? Now look at this guy. This guy has a slope of 1. It's going to cross the origin at 0. So that one's actually pretty easy. And I said 1. It has a slope of -1. It's falling. The first piece from left to right is the -x. And it's valid between x values of -3 inclusive and 2 non-inclusive. So -3 less than or equal to x less than -2. Then we have this constant. Y is just 1 there. And it is valid from -2, known as the solid dot, all the way until x hits 1. I forgot my symbolism there. The next piece I have is this guy. It looks to me like it's, if we work from right to left, it's falling 4 and running 1. And think about y equals mx plus b, kids. Rise 4, run 1, 4x. We would cross at -5. And it is valid from 1 to 2 on x. 1 less than or equal to x less than or equal to 2. That's really how easy it is to come up with a piecewise functional graph. Now, the idea here is that a kid knows how to write equations of lines. That's why we teach that skill to you at an early age. It's a big deal. Like, you need to comprehend that that's a big deal. Those things that you thought were stupid in 7th and 8th grade are going to make you look stupid now. So figure them out, please. I know nobody wants to feel stupid. How can you rewrite the function f of x equals 6 plus 18 as a piecewise function? It's actually as easy as writing it the way we solve and determining where the vertex is. So we're going to determine the two equations, just like we do when we solve, and we're going to think about where the vertex is. And we're just going to go ahead and graph it. So let's go ahead and pull that 6 so we can graph it. If we pull a 6 from 6x, there's an x left. If we pull a 6 from 18, there's a 3 left. And the vertex would be over here at -3. And then we would rise 6 and run 1. And we could spend a lot of time doing y equals mx plus b over this. But think about how you were taught to solve. To solve an absolute value equation, you literally write two equations. Remember that? To solve absolute value, you write two equations. The first is as is. The second, we change the signs of everything inside. So one of the pieces is 6x plus 18, and the other piece is -6x minus 18. Now you can kind of look at the graph we came up with, and you should be able to figure out pretty quick that this piece is the 6x plus 18, and this piece is the -6x minus 18, because it's falling, and it's going to cross around -18. And something happens there. There's where it becomes two different pieces. We are -6x minus 18 all the way from -infinity up till we hit -3. Or we might just say x is less than or equal to -3. It's a lot easier to do this. Nobody does this with interval notation here. And then we become 6x plus 18 as soon as x becomes bigger than -3. Notice only one of them has equality. They both can't have equality because then you wouldn't know where to feed it. Moving forward. Write a rule for the absolute value function, and it's kind of the same idea, and I'm only going to do example A. You need to be thinking about your graph. Okay, you can pull the -5, that'd leave you with x plus 2. Make that make sense, kids. That'd be a right 2, and then we would fall 5. Yeah, there's my v. And this is the big deal. Alright, that's where x equals 2. One of your equations is as is, -5x minus 10, and that's going to be interesting. Oh, I went the wrong direction with this thing, didn't I? Oopsie poopsie. I should have gone left too. Even I'm guilty of that. That would be this piece right here. That's the -5x minus 10. So it takes over when x is bigger than -2. The piece on the left, which is the one I actually want to talk about first, is that one. Usually, generally speaking, when you change signs, it's the piece on the left. I think that's always true. I can't say for certain it's always true, but I feel like it is. That happens when x is less than or equal to -2. Boy, that's bad looking. It's like I've had too much caffeine or something. And there's your piecewise function. We just call it f of x equals. Alright, I'm done with that one. I'm not going to do the bottom one. And then we have given this function, -2x plus 4, so long as we are between 0 and 8, and -5x plus 11, so long as we are greater than or equal to 8. Is the function increasing or decreasing from 2 to 7? Find the rate of change over this interval. Okay, so I can do this with a graph, or I can do it numerically. I like graphing. That's me. If I feed this thing a 0, it returns a 4. If I feed this thing an 8, it returns a negative 12. Negative 2 times 8 is negative 16, add 4. And no equality. Okay. Decreasing. The rate of change over that interval is the slope. It was a line. So the slope is negative 2. And it's always doing that. And there you go. I didn't actually have to graph the rest of the function. So there you go. That's it for that set of notes. I hope you enjoyed. 26 minutes. It's going to be tough to do during class time.